Stress. So, what is stress? Now, most materials in engineering undergo stress. All materials undergo stress. When force is applied on a material, if the material is having a change in dimension or shape, that material is said to be in a state of stress. So materials can also be in a state of stress when a force is acting on the material and causing the material to have a change in dimension or in shape. So we are saying that stress is the change in dimension due to the application of a force. All right, so that is a very important point to note. And also for the formula, we say that stress is the ratio of the applied force to the cross-sectional area of the material. Also, stress is the ratio of the applied force to the cross-sectional area of the material. All right. Now, before I state the equation for stress, I want to show us the symbol for stress. The symbol we use for stress is giving us this symbol. Look at this symbol, guys. This is a symbol for stress. Now, we use this symbol if the stress is a compressive stress or a tensile stress. I repeat that. We use this symbol. This symbol is called sigma. It's called sigma. Okay? Now, we use this symbol for stress if the stress is tensile or compressive stress. For tensile or compressive stress. All right, so here is one symbol for stress. Also, we can also use a symbol for stress which is called tau. It's called tau. All right, so tau is a Greek letter spelled as T-A-U. All right, here is another symbol we use for stress. So when you are giving questions, you must be very careful what you are using for stress. If the stress is compressive or tensile, we can use this symbol here. Okay? If the stress is a shear stress, we can use this symbol. It's used for shear stress. For shear stress. All right, so these are the symbols we use for stress. So therefore, we said that stress is the ratio of the what? Applied force to the cross-sectional area. So for a tensile or a compressive stress, the formula is the stress equal to force over area. Good. For a shear stress, the stress becomes what? Stress equal to the force over the area. This means that when you are given a question, you must be very careful to know which of these symbols you are using for stress. If it's compressive, we use this. If it's tensile, we use this. But if the stress is a shear stress, we use this symbol. Now, we must note that the unit for stress is giving us Newton per meter squared, or is giving us Pascal. These are the units for stress. These are the units for stress. It's either in Newton per meter squared or is in Pascal. And I hope we all know how I got that unit, because the force is in Newton and the area is in meter squared. So that gives us Newton per meter squared. That was how I got the units for stress. Now, I want us to note another important concept that we use when solving questions. Because we are dealing with stress, you will be seeing large values and big values as your answer. So we can use what you call prefixes or prefaces to reduce such large digits. For example, we have what is called kilopascal. Now, 1 kilopascal is equal to times 10 to the 3 Pascal. We have megapascal. 1 megapascal is equal to 1 times 10 to the 6 Pascal. I'll give us a next one. It's called gigapascal. This is 1 times 10 equal to, or 1 times 10 to the power 9 Pascal. Okay, so these are some prefixes we can use when solving questions. That means that you can reduce your answers to either kilopascal or to megapascal or to gigapascal. I will show us in the examples below. Okay, so here is a question, and it's saying that a wire of circular cross section has a tensile force of 80.0 Newton applied to it, and this force produces a stress of 5.01 megapascal in a wire. Calculate the diameter of the wire. In this case, the first thing we do is this: we write out our given data. So I have my force is given to me as 80.0 Newton. I'm given the stress. My stress is given, as you can see, it's a tensile stress. All right, it's a tensile stress, so I will use the symbol. Tensile stress is equal to 5.01 megapascal. Now I can convert these to Pascal, because I know that mega means times 10 to the power 6, so I can say becomes 5.01 times 10 to the power 6 Pascal. Okay, now we are asked to find the diameter of the wire. Now, to find the diameter, step 1, I have to find the area, right? Because I know that the stress is equal to the force over the area. So for me to get my diameter, I have to find the area, and I will transpose this. We now have what? We now have the stress times the area equal to the force. So I will divide both sides by the stress. So stress cancels stress. So therefore I am left with area is equal to the force over the stress. So what next? I will log in the values. So my force is 80.0. over the stress is 5.01 times 10 to the power 6. So I can find my area, and please note that when you are finding your area should be to 4 decimal place. Your area should be to 4 decimal place. So when I find my area, I get 1.597, 1.597 times 10 to the negative 5 meters squared. So that is the value for my area. Now, what I do next is to find the diameter. Now, this material is a circular object, okay? So I know that my area can be equal to, the area of a circle is what? Is pi r squared, or pi d squared over 4. So I can use this formula to get my diameter. So I can say my area is equal to pi d squared over 4. With this formula, I can get the value for the diameter of the wire. So my area is 1.59, 7 times 10 to the negative 5 equal to pi times d squared over 4. Please, pi is not just 3.14. That is not accurate. So I will advise us that when solving questions like this, use your pi as pi. Just press pi as it is in your calculator. Please don't change pi to 3.142 or 3.14, please. That will not give you the accurate answer, okay? So what next? We cross multiply. So I have a pi d squared equal to 4 times 1.597 times 10 to the negative 5. All right, so we now have pi d squared equal to 4 times 1.597 will give us 6.387, give us 6.387 times 10 to the negative 5. What next? We divide both sides by pi. So I divide this by pi, I divide this by pi. So pi cancel pi. So my d squared is equal to 6.381 times 10 to the negative 5 divided by pi will give us 2.033 times 10 to the negative 5. Okay. So what next? We take the square root of both sides, square root of both sides. All right, so the square root of d squared is d equal to the square root of 2.033 times 10 to the negative 5 will give us 4.51 times 10 to the negative 3 meters, or you can say is 0.0045 meters. So this is our final answer for the diameter of the wire. Now, question 2, we are asked to calculate the stress in a tube of outside diameter 60 millimeters and inside diameter 40 millimeters, subjected to a tensile load of 60 kilonewton. The first thing we do here is to write out the given data. I'm giving the outside diameter. I will use D subscript O is 60 millimeters. We have to convert this to meters. It becomes 60 over 1,000. That gives us 0.06 meters. Next, we have the inside diameter. I use D subscript I is 40 millimeters. We convert again to meters. Is 40 over 1,000, and that gives us 0.04 meters. Okay. Also, we are given a tensile load of 60 kilonewton. That is the force. All right. We are given the force of 60 kilonewton. We can convert this to Newton. It becomes 60 times 1,000. And that gives us 60,000 Newton. Now the question is, we are asked to find the stress, and I know that the stress is equal to the force over the area. Good. But to get the area, I have to use the formula because it's a circular object. So the area is equal to pi d squared over 4. In this case, I'm giving an outside and an inside diameter. So I can say pi over 4. All right. Open the brackets. Outside diameter squared minus inside diameter squared, bracket close. With this, I can get the value for my area. So therefore, my area is equal to pi over 4, open brackets. My DO is 0.06 squared minus my dr is 0.04 squared. So when you put this in your calculator, you should get area is equal to 1.571 times 10 to the negative 3 meters squared. That is our answer for the area. Now I can find my stress. I can log in the values. The force is 60,000 divided by the area is 1.571 times 10 to the negative 3. When you put this in your calculator, your stress should be given as 38192234.25 34.25 Pascal. All right. So this is our answer for the stress, but we can reduce these large values using one of our prefixes. All right, so I can reduce this to a megapascal, so I will move the decimal points backwards, so it becomes 1, 2, 3, 4, 5, 6. That is mega, because 6 is mega, so that becomes what? That becomes that gives us 38.2 times 10 to the 6 Pascal. Or I can say is 38.2. This is mega, so I can say 38.2 megapascal. So that is the stress in that tube. So here is our final answer, 38.2 megapascal.